Hello dear viewers, welcome to Geonodes Daily series where we do something cool in geometry nodes and we try to do it as fast as possible. Welcome to the second part of this SciFi Reactor project where we will recreate step by step this awesome scene that you see here. In the first part, if you haven't watched that, I encourage you to do it. You can see how you can create a crate that can be broken into triangles and control that effect by an empty. Today we will tackle the second part, how to turn that single crate into a pile of crates, and not any pile, but a procedural generated one with a bunch of controls. That will be the final project, the one that you see here in the image. You can download this project file from Gumroad and play with it as much as you want, and also support the channel while doing it. As you can see, this project has a lot of controls. Here I went through them in the first video. I'm not going to go again through this, but you can control the effects that you saw in the image, the exploding effect, the crates, everything basically. So you can get a lot of variation out of this project. So let's leave this one aside and go back to where we left yesterday. We created this crate that you can turn into triangles with the help of this empty. And now we want to turn this single crate into a bunch of crates, a pile. So that will be the first point, creating the Z stacking. And because we want to multiply this crate, we will go after the first part where we created this cube that we triangulated, and we will multiply that one. So how can we do that? We have this instance on points that we can use, and let's do this for the instance, and I'm gonna plug this one here, and as you can see, everything disappears. Why do you think is that? Well, because we have no points to instance on. But like I said last time, it's important to keep things organized, especially on big projects. So let's do a group for this and call this generate crate piles. Excellent. So now we will know what this does. So what do we want to add here? Well, let's do a mesh line, and this mesh line will be our instancer. And as you can see, immediately we get a pile of cubes here. So let's put this one in into this frame. Okay, excellent. So we know it's from this stuff. And as you can see, we get this pile of crates. If we play with the empty now, you will see one problem, that basically every single instance gets the same deformation. You can see it. And that's a problem with instances. They are a lot faster to calculate because the Blender don't have to do all the calculation for every point for every instance. It does for one instance, then apply this calculation to every other instance. But when you want to get a differentiated effect, that's kind of breaking apart, as you can see here. But at the end of this video, I'm going to show you how to fix that. For now, let's just leave it like this. We don't really care for that. We want to do a bunch of things with this pile, because right now we have a control, is true, but this control is just for the height. So let me expose this value, integer. We want an integer, and I'm gonna plug it here, and let's say for the beginning 5 piles. And because this is an important setting, I'm gonna do it a color on it. Let's put something like a greenish color. By the way, you can save presets by going on this menu. You give it a name and you click plus and you have a preset. For example, I have something for input that looks like this. So now we know this value is number of piles, number of crates, sorry. Excellent. This will be the first step, but we want to do a bunch of stuff with this. We want to create more than one pile. That will be one thing to do. And not only that, but we will want also to do the piles offsetting. So some crates will go like this, some crates will go like this. We also want to control the scaling, so some crates will be smaller, some crates will be bigger. We want also to control the rotation, so some crates will be like this and some other will be like this. So basically we want to add a lot of controls to this. So let's get to the first one and do the pile spacing. So how can we do this? Well, we want to control this position of these points. So I'm gonna do a geometry set position and plug it here to control the points of this line. And now we can play with this positioning. So I'm gonna take the position and do a combine XYZ on it, and everything immediately gets turned to 0 because we stacked everything at 0. Let me make a new group for this and call it stacking crates. Excellent. So now we can control the location of this, and because we want to make something that takes into account the scaling of the crates when we will do that later, I'm gonna use this very cool node called accumulate field that will allow us to do a bunch of cool stuff in a procedural manner. So let me plug this one here. And for the Z, I want to calculate the center of our box, the center. And in order to do this, I'm going to take these two values. So let me take a math node and add is perfect. I'm going to take the leading and the trailing value. And then in order to get to the middle of that, I'm going to take the result and switch this node to divide and divide it by 2. So basically we take the first, last, divide it, and then we get this value that will be our Z. And as soon as we do this, as you can see, our boxes are nicely stacked on top of each other, no matter what the scale will be. And that will be controlling the scale later on. For now, let's leave it at 1. This is the size of our box, 1. That's why they stuck perfectly on top of each other. But for now, we will leave it at 1, like I said, because I want to do the spacing part. That was the stacking, and I want to do the next part and add some offsets for these crates, and the offsets will be on this value, on the Y. As you can see, if we play with this value, we can move the entire stack, or this being a diamond shaped socket means that it accepts more than one value, like I said in the previous video. So we can do different offsets for every single value that we have here. So let's do a random on this one. I'm gonna plug this one here and plug it here, and immediately you see the stack being offset, and we can control the minimum and maximum value of this offset any way we want. So in order, for example, to get a controllable value, let's do an input. Let's do a value here. And I want to know this is an input value at a glance. So let's say 0.3. And I want to have a 0.3 here. And I want the inverse of that to be here, minus 0.3. And the way to get the invert of that is to take the value and multiply it by minus 1. So now the output of V will be minus 0.3. And then we get something like this. So let's call this inverting A. Excellent. Now we can control how much this gets offset. Great. But how can we do the pile spacing? Well, we can play with this value here, and we will space them on the X value. So let's do just that now. We will also use a random value for that. That will help us to break this single pile into more than one pile. So let's put 10 crates here. And this accumulate things field has this group index that will split basically the crates into different indexes. So let's create a random value for that. And I want to do another frame, and this will be crates piles. Excellent. And I want to have a random value. I want this to be an integer because this will control the index. So once we did this, I want to have this is a value that I actually want. This is our offset control. Excellent. And this will be piles number. Okay, excellent. So now we have this. Let me switch this one to integer. Excellent. Shift S allows you to switch an node if you have the node Wrangler add-on enabled. And now we have a piles control. So let's say we want 3 piles, for example. And now we can say that we want to generate a random value from 0 to this number. Excellent. Now we see that things are not changing because basically what we did, instead of having 10 boxes stuck on top of each other, we have these values stuck on going inside of each other because they are still sharing the same X location. But now we can change that because, for example, if we take an utilities node and we switch this one to multiply, and we take this output. So remember, now we have 3 piles basically going from, let me show you. If we look at the output of this node, in the context of this geometry, we have 3 groups, 3, 0, 1, 2, and 3, basically 4 groups here. In order to get only 3 groups, we will have to do a little bit of math here. So let me take this one, switch to subtract, and plug 1 here. So now we have 3 piles instead of 4 because we have 0, 1, 2 maximum. It's more intuitive to have 3 here and subtract 1 and get 3 piles like that. And we have 3 piles. They are sharing the same X location, but we can change that because we can take this value And now we can have, let's say, another value here. Shift S, I want this to be a float, and this will be our piles spacing value. So let's say 1.2, for example, plug this one here, and the output of this, we will plug it to X. And now if we look on the X, we have these 3 piles, we have this offset, and we can control just how many number of piles we want. So this is how we can get the piles to be spaced, and we can control the number of them. So let me put these values here into this node group, and this one is also no, this one will be the spacing. So let's do another group for this and call this one piles spacing. Excellent. Now we know what this does. And the next thing that I want to do is do the scaling. Yeah, let's do the scaling. And for that, we will use another random value. So let me take a frame and see, do crates scaling. Excellent. And add a random value, plug it here, and take this number from here and actually switch it to a value. Shift S, switch to a value, or I can simply take this node, plug it here, and this will be crates minimum size. And let's put this one 2.5, for example, and we'll have this, and maximum will be 1. And now this value, we can plug it into our scale here, the scale of our crates. And as you can see, we have different scales, but we have this problem. They don't stack anymore. But if we plug this value here into our accumulate field, the value that we generate here, we see them stacking nicely because we have this value for each and every instance, and we calculate the basically the center of this pile basing on the size of each and every one of these crates, and we use that for the stacking value. So now we can play with this stacking as much as we want, and our piles will be just fine. And now I want to do something else. I want to show you how we can make these piles rotate a little bit. So we will add another control for this. Let me take this triangulate here, and given the fact that all of these are basically part of our pile group, I'm gonna add them to another frame together, and I'm gonna take this frame, and I'm gonna call this one crates piling, and I also gonna give it some color, and that color will be something like this to differentiate from the background. So let's do it something like this. Yeah, that's great. And now in order to control the rotation, we will do another group here. So let me push this one here, and let me take this frame, and this will be random stack random crates twist. Excellent. And if it's random, we will use a random value. And I want to have something like pi, that means 180 degrees. I want to have half of that. And that means a rotation from minus 90 degrees to 90 degrees. And this is going to be plugged into the rotation. But I don't want to rotate crazily. I want to basically take a combined vector, plug this one into the rotation here, plug this one into our rotation stuff, and just control the rotation on one axis, this axis, because I don't want the crates to do something like this, some crazy thing like this. I just want them to be rotated on the Z. And as soon as I do this, we get this random twisting rotation, as you can see here. Awesome. And that's gonna be done for this part. I'm gonna do an overview of this, and I'm gonna tell you what we are going to do for the next one. For the next one, we will do a setup that will allow us to randomly mix materials for these crates. Right now, they don't have any material. We can give them one material, but I want, for example, to have randomly 3 materials, something like this. And they will be distributed in the random fashion like you saw in the demo. So this is what I want to do for the next video. But a quick recap what we did today. We took the cube from the first tutorial and we instanced it on a line, the line that controls the number of cubes that we have. And then we move the position of the points of that line so we could do the stacking. The stacking is here, and this is what allows us to play with different values. We could do this setup here, accumulate field that it's calculating basically regardless of the size of the crate, it's calculating its center and it's using that to properly arrange all the crates. And then we played a little bit with the Y offset to make the crates go left and right by using a random value. And then we made a controller for the piles by controlling the accumulate field group index, so basically splitting the instances into groups. And now we can control just how many piles we want to have. We created this variation using this group value that it's if we look at it again through this value using a viewer node, the output of this random node is giving us a group number, a random group number, and we are using that group number multiplied by a value that we decide to establish just how far apart these piles get. So this is how we can control the spacing, because we are basically multiplying the X location of each pile with the group number and with this value that we decided. If we put it on 1, they will be basically touching each other. If we want some spacing, we use this value. So in order to make for this to make sense, all the piles in that group, in that pile, will have a group ID of 1. This will have a group ID of 2. This will have a group ID of 3. So that's why they all being pushed the same amount, and they are placing this at the corresponding locations. What else did we do? We control the scaling again using a random value, and we decided a minimum value for the scaling, so we can play with that as well. And because we use this accumulated field again, we made sure that the piles are sticking on top of each other no matter their size, because we calculate the center of each box based on its random size. And at the end, we did a twisting by playing with the rotation of the instances. And then, as you can see here, we used another random value. I promised you that I'm going to show you at the end how you can make this work on each individual crate, this deformation that we did in the first part, because right now all the piles, all the crates get the same deformation. And in order to make this work properly, there is one thing that we need to do. And the thing that we need to do is, let me get rid of this viewer node, we don't need it. It's to turn these instances here into real geometry. So let's go to instances, realize instances, and we have to plug this right before we start the nodes that do the breaking part. So if we plug this one here, and let me give it an important color, this is let's call this prepare for breaking effects. As soon as we do this, we don't have instances anymore, not after this point. So we can basically use this empty to control each and every box individually. So, like I said, this is all for this tutorial. In the next one, I'm going to show you how you can assign random materials for crates. Until then, happy blending and have a nice day, and don't forget to support this channel by subscribing, liking the videos, and commenting on them, and purchasing the projects from Gumroad that you can use to do whatever you want. So